Okay, welcome to ICE Education. So today we'll be doing, what is it called again? Buckingham Buckingham Pie Theory. Okay. You can see from your textbook basically what you guys are doing. How can I explain it in the easiest way? Do you remember when we do calculation in physics or in mechanics we have units? What is the unit of force? It is Newton. You know that force is Newton. But Newton can also be expressed in another way. If I remember well, Newton is something like ml over g, something like this. Now, where does this come from? Look what happened. You know that velocity is meter per second. So what is meter? Meter stands for distance. What is s? S stands for time. So what is the Buckingham theorem about? Basically what you are doing, you are simply deriving formulas by using these parameters. Now in mechanics or physics we have three how can I explain this, we have three main parameters, which is the mass, which is the length, and which is time. These are the three parameters that we do study. We don't consider temperature in this case, we study these three. So now basically what's happening is when you look at this system, Mr. Photo, you are doing it using the Buckingham 2 theory, what, but you'll see it's nothing hectic, it's quite straightforward. Basically what happened is you have a function, and you know that function v, it is based on g and h. You need to solve this by using the Buckingham theorem to get the expression without, okay, okay, to get an expression without the parameter. Remember when we solve for force, what do? We put Newton to get the answer without those parameters of Newton, those ml and what's going on there. I know it looks strange as I'm saying it, as I'm whatever doing it, but as we do it, you see this chapter is quite straightforward. So I've heard that we should do example 1.8. I'm pretty sure we can do it fast. We can do 1.8, we can do 1.2. I just want to confirm, is this all for chapter 1, Mr. Koto?
For what we did in class in our first class, that's all. But let me do this. After this class,
Hmm.
I'll check on Blackboard our slides that you said. Maybe he had included some other things, but I'll check after. But those two, he said we must do them.
Yeah, no problem. So we'll focus on this one. We're gonna do them, and I'm pretty sure, like I said, if you do understand this, believe me, there is no. Actually, this is straightforward. Right? Now, what is Buckingham theory again? This is what happened when you do the Buckingham theory. They explain the step here. What is they said? Dimensional analysis, step by step. Pi function of pi 1, pi 2, pi n. Okay, what are the pi standing there? It's simply the number of variable that is given in your equation. Now again, I'm speaking, you're asking yourself, what are you saying? But you will see as we solve. Let's just go to quickly this step and then we can go to that example. They say identify the significant dimensional variable and write out the primary dimension of each. What are the primary dimension of each? Remember, I've said under this topic we have three main primary dimension, which is the mass, what is the length, and what is time. And if you notice, all our units that we've been seeing from physics, matters of unit, from physics, mechanics, thermodynamics, they all they all, how can I say it in a good English? They're all lying around those main dimensions. Applying the Buckingham theorem to find the number of pi. That's a good one. How do you find the number of pi? You will see. Set up the table with row equal to the number of dimensional variable and number of column equal to the number of the basic dimension plus 1. Okay. List all the dimensional variable at the first column with the primary dimension. Select the dimensional to be eliminated variable column. What? Select another 6 what? Repeat whatever. Let's see how it is done. Now, Mr. Roto, as you can see, there's actually a lot of way to do this. Personally, last year when I did this, I did it with the exponent method. This method of exponent. It is fine. You get the same answer at the end. But what we're gonna do, we're gonna do this one using the Buckingham theorem. And if we check the slide, they say we should do it as a theorem. We'll go for it. But as for now, we focus on the Buckingham theorem. So now, if you look at this example here, what are they saying? For a body falling in vacuum, they said velocity is a function of g and h. Now, what does this mean? Remember when we say, let's say, f of x in met, the function here is 2x, let's say, plus 2. This is f of x. This is function of this. Literally, how you can call it again, you can say x is function of 2x plus 2. It's kind of math related. So basically what's happening is, guys, if I said, I come to a problem, I said velocity is a function of g and h. Is it that? G and h. Okay. Now, what's happening now? They said, they said find the pi groups. Okay, find the pi groups. We simply want to check using the Buckingham. This is how it see. They say pi 1 is equal to function of this. So you're gonna find out how many pi's do you have. Now you will see in some other cases they talk about m and n. That's where they're saying m plus 1 and what there. But you will see it's quite straightforward, Mr. Watson. Now, for you to know the number of pi that you are expecting, this is what happened. Number of pi, it gives you the number of variable that you will be having in a solution. Let's look at this second example. You will see what I'm talking about. We're gonna do the first one. Let's look at this one. Actually, the method is quite simple. What do? You count all the variable. With that I mean, you see the word f of d is equal to function of v u mu d. You count them. Now when you count them, how many are them? 1 2 3 4 5. 5 here stand for is it m? Yeah. Now you want to know the number of pi that you will be having at the end of your solution. Next thing is to find n. Now how do you find n? Remember I said you have 3 primary dimensions. So what do is you check from these guys that you are given here, are they having those primary dimensions? When I look at the first, I have m, l and t. When I look at velocity, I have L and T. When I look at density, I have ML. You can see throughout I have the presence of M, L and T. Because of that, I definitely know that my value of N is 3. How do I know it's 3? Because I see M, L, T. Now for me to know the number of pi group that I should expect as answer, you simply do M minus N. So under this case it is 5 minus 3, which gives me 2. Now how is this related to the answer? The good thing is you can track your answer due to it without even knowing the solution. I know at the end of the day When I write my solution, it will depend only on two variables. I'll be having one on side here and then one function on the other side here. I don't know if I still have my test of last year where you had four variables. You have 2 pi. It's even written here. You have pi 1, which is this one on this one, and then you have pi 2, which is this one on this one. So now, when you find the number of pi by doing n minus n, it tells you what you should get at the end. So actually, this thing is leading you to the answer. I don't know how to say it. It's directing you. You know what to expect. Now let's move to the first example and do the same thing that is here. Okay guys, let's see what's happening. Actually, for you to do this properly, guys, you need to remember the unit, or what you can do is you can look at this example when it comes. These are the one that you will be having. I won't lie to you. It's either this density. All you have to remember, okay, you know the unit of density, right? You know that density, when you put it, is kilogram meter square, meters cube. Kilogram stands for mass, meter stands for distance. That's why you see ml cube. That's how it is written. It is simply the unit that you are converting in the primary dimension. That's one of the reasons why you have ml cube. Simple as that. Now, what is force? Force is it is Newton. What is Newton again? Newton, what is it again? I can't remember it, but with this I can have an idea of what is Newton. If they say
Tell me, is Newton
Newton is
or is Newton kilogram per meter square?
let's see, if they said F, it is M,
Because isn't it mass multiplied by acceleration?
it is mass. Yeah, they said it is ml divided by, or is multiply, it is mass multiplied by acceleration. Yeah, yeah, we'll check it now. You just have to remember this. Someone wants to join. Let's add the person first. Mr. Kabamba.
Oh, sorry, not kilogram per meter square, but it's kilogram meter square. Sorry,
It is kilogram meter
kilogram multiplied by meter square.
by
Yeah,
meter
yeah.
square. Okay, we know that.
Not
Yeah,
by, not by, multiply.
yeah, it
Because
is
by is like dividing.
multiply by meter square.
Yeah, yeah. You know it's right. Yeah,
So therefore, what is happening here? So kilograms stand for mass. We have mass. Mr. Bubakar, let's double check. Let me check
No,
your.
as it's the SI unit for mass and acceleration. It's kg multiplied by
Per second square.
meter per, yeah.
Yeah, that then it makes sense. Basically, what you have to do is to remember this unit.
sorry. Yeah, it's
Okay, you see what's happening here. When we came in varsity, we're just writing the unit. Now we are deriving the unit. This is basically just what's happening. I don't know. This guy called Buckingham will come with this idea. So unit of force, you guys said it is kilogram multiplied by meter per second square, right? So therefore, you know kilogram stand for the mass, meter per second, meter here stand for the distance, that's why it is L, time second stand for time. Already it is here. You already see 3 parameters, so it means if you have a problem, you already see 3 parameters. Just know your n under that problem is 3. Simple as that. If you want to know the m, you count all the variables. You do count them. Now, Mr. Kotso, I believe that you guys are with me. So now, what's happening here? Let me try to pen it so that we can take that example. Under that example, they said v is a function of d and h. Now, when I count my variable, Mr. Coates, what is it? 1, 2, 3. I know that m is 3. Now, what is happening now? I need to write each and every element but with the primary dimension. These are the steps. So what is v? What is unit of velocity? You know velocity is meter per second. Otherwise, it is distance over time. Now, what is gravity? What is gravity, Mr. Koto?
Meter per second squared.
Is it not an acceleration?
It is
Is it
acceleration.
a force?
Gravity here is it's not a force. G, it is 9,8. Is it meter per second square? Yeah, it's acceleration, it's not a force.
Yeah, it's an acceleration. Meter per second.
You know it is meter per second square. So therefore, what do we have? Meter stand for what? L. Second stand for time square. Easy as that. What is h? H is the height. It is expressed in meter. H and distance, they are the same. So therefore, h here, under this case, it is simply L. Now, what's happening is we will write this function here without this primary dimension. This is just basically what we are doing. But let's see how it works. This is basically what is under example, under this example. So the first step is simple. You write everything with the unit of the primary dimension. Now, what is the second thing to do, guys? If you remember, we can count what is our n here. The n we can see here is 2, guys. Remember, we have 3 primary. It is m, l, and g. Under all these expressions, we do not see the mass. So in this case, you know that n here is 2. But remember, if you want to know the number of pi, it is what? It is m minus n. So basically, it is 3 minus 2, which gives you 1. Now this justify even without even moving. When you check the solution that they got on the example, you can see at the end why you only have 1 pi. Any question?
Mr. Ice,
Mm.
Mr. Ice,
Yes, I'm listening, my brother.
yes. Oh, why did you say n is 2?
Oh, I said
Why
n
did
is
you say
2.
n is 2?
When you look at this function here, Mr. Koto,
I'm saying, why did you say?
yeah, I'm explaining it. V is a function of g and h. You see, Mr. Koto, when you express them in the primary dimension, here you have lg, here you have lg, here you have l. You don't have the presence of the mass under this function. Remember, we have 3 main primary, m, l, and g. They are the one that makes 3. But for you to get it 3, they have to be in one of the expression of our function. But under this example, when we check our function, when we write them in terms of primary dimension, we do not have any m. So therefore, we are only having l and g. That's what makes n to be 2. So it's depending on the problem, Mr. Coates. Did I answer you, my brother?
Thank you, Mr.
So now you know it is 1. That's the reason you know that you are only expecting one answer of pi. That's the reason under the solution here, without even finishing the question, I know that this one here should be like this, the pi solution. So now let's get to the pi solution. Here we are using Buckingham using I can call it division method, because there are actually 2 or 3 methods. You can do it using division method, you can do it using exponential method. Yeah, these are the 2 that I know, but I believe that there is one more. but you don't need to know them all. We're gonna do it using this one. So now if you want to do the table method, what you do is you write the variable. I don't know if I should copy this table or draw it. Let's do this. Mr. Bubakar, are you with me,
Hey,
my brother?
Mr. Ice.
I'm listening, my brother.
He said that we
Yes, I
must
am.
focus. He said we must focus on the equation of similarity and the step by step. He said those ones are the ones that are going to come up. Step by step and similarity.
What does it mean by similarity? Step by
Similar.
step is this thing that we are doing.
Yes, he said similarity analysis.
Why is
That
similarity?
was for our second class.
Hmm? Uh, Under the second class, under similarity, do you have a question or something that you guys wrote in class?
8.4. Example 8.4.
I
Or example
he
8.4?
gave us two methods.
Why is it again?
Example 8.4. I didn't write the page number here.
That was 8.3. What is example 8.4? This is similitude. I don't know if it's similitude that you wanted to say. Let me. I'm scrolling. Maybe I will find the example. Oh, this one here.
Yes, that one. That one.
Oh, okay. So let's do that one and then yeah. Under chapter 2, what is it again? I'm pretty sure if we push hard, we can finish this topic by tomorrow. And then Wednesday we finish the other one. You guys will be fine. The test won't be difficult. Just need to understand what we are doing. So you guys don't need to do the
But isn't you say we write? How many chapters are we writing on? You say
two.
one chapter. Isn't it? Only chapter 2.
They say two chapter, right, Mr. Colson?
No,
Uh,
it's
it's
only
like
one chapter.
it's
One
one
chapter, but
chapter, two topics.
yes,
Oh,
yes.
oh, it is this one and that other one. Is this
Yes,
example?
he said you must only know that.
Those two. We should be fine, guys. Let's focus. Let's do example 8.1, 8.2.
No,
You saying, my brother?
no, there is that other one.
Which
The
one is?
other one is like one chapter that has like two topics. This one that we are doing, and there is another one
Oh,
down.
okay, okay,
Yeah.
no problem. But let's move. Let's move, Mr. Coach, my brother. This is the step by step. This is what they call step by step that we are doing. Okay, basically, I just copy this table because yeah, I'm lazy to write. Okay, but what's happening is what you do is you write these guys that we have here: V, G, and H. Now, alongside here, you write the thing with primary distance. V, you know it is L over G. Mm, G, you know it is L over T square, and then H here is L. So now what happened is, how do we get to this end answer here? This is using the division method. What you do is slowly by slowly you cancel out these primary dimension until you reach the final answer. What do I mean by that? It is important. You can select which one do you want to cancel, but let's see. Here under this example, always go for the easiest one. Look at here, you have L on its own. It means you can cancel L. How do you do it? When you cancel, it means you keep it empty, like you're not gonna use it. But if you are using L as cancelling, remember L is coming with H. Do you guys see it? If you want, let's look at this first expression here. If you want to cancel L here, what do you do? Remember, it is L over G. If you want to cancel L, what do? You need to divide by G. Do you guys see? If I put L here, L will cancel out. Do you see it, guys? That's the division method. If I need to cancel L here, I need to divide. But what is L? L is also H. So it means that's the reason why you do have now, under the variable, you do have V over H with the new parameter distance of 1 over G. I know that sounds a bit crazy. I'm gonna repeat myself. Let's see what's happening. You do have V, which is L over G. You do have H, which is L. Now we want to cancel L. What do? You divide everywhere. You divide here. Do you guys agree? If I divide, what will I have? I'll have V over H, and then I'll have L over LG. Now I know L will cancel. Definitely now I know I have 1 over G. So now I have a new expression of V over H with new main dimension of 1 over G. When I'm done, I move to the second expression. I also want to cancel L. What do? I divide. You can divide, you can multiply when you do the table. It depends on how it is suitable for you to cancel. What do I mean by that? I'm just gonna go back to the second example that we will see. Let's look at this one here, guys. You have L, right? And look, you have long expression. Always start with the easiest one. Choose the easiest one. It will simplify you to cancel. You can start with the big one, it's up to you. But remember, if you start with the big one, you will be having big expression. If you're not focused enough, that might confuse you along the road. Now let's look at this one here. It's not that every time you divide you have L, right? If I have L here, let's look at these two. I want to cancel L where there's mu here. Sorry. I want to cancel L here where there's mu here. Under this case, I will not divide, I will multiply. That's the reason you have mu times d, because when you multiply, L will cancel the L down. So it's a matter of placing it the way you want. That's the good thing about this topic. You make it the way you want. Like under this case here, because I want to cancel L, I need to divide. So it means that's the reason also you have a G over H. Now what would be the new guy here? Is going to be 1 over G square. Now again, you still have T. It's up to you which one do you want to choose. But when we look at this guy here you have T, here you have T, here you have T square. Which one do you think is the easiest one to use? You can go with square, you will get the same thing. You can go with the simple one, you will also get the same thing. So it's a matter of, okay, I see it, I see the similitude. Okay guys, let's go. I believe you guessed what I'm saying. So now what's happening here is the growth. You have V over H to be 1 over G. You have G over H to be 1 over T square. But remember, you want to cancel one here. What do? What do you do? Now if we want to cancel one here, what can we do? Do you agree that if I want to cancel, I can make an expression of chi here just for it to make it look easy? Do you agree that This simply means this. This actually what it means. If you make a chi subject of the formula here, what do you have? You can trick it like this. You're gonna be having you cross is gonna cross multiply like this, one like this. So if chi come here, you're going to have h over v. I believe you guys see it. Now, if you want to cancel this t square here, what do? You need to multiply this expression by t square. Do you agree? So now, what does it mean? It means the expression g over h here will also be gonna be multiplied. This is t. What is t square under this case? T square is h over v square. That's what it means. So now, since you will be multiplying, so what you will be having would be h square.
You said t square is equal to, sorry, ice.
Yeah. I said t square.
It's ice
Yes, I'm listening.
is equal to h over v square.
Mm. I'm using.
But it's t square.
Okay. Do you see what's happening? You have this to be 1 over t. You have this to be 1 over t square. You want to cancel t. Do you see it? All you want to cancel t. How can you cancel t?
Yeah. I see it. I see.
The way you can cancel t is to multiply by t square here. But remember, t also have an expression. This is basically what we are doing. This is t. When you square it, it becomes like this. Now you are multiplying so that it can cancel. So basically what you are having is h square v square, pay attention, multiplied by g, everything divided by h. Now what happened is t square on the other side, it's going to be t square divided by t square, which give us the number 1, which we call it to be a constant. Or you can keep it 1 first like this. Let's keep solving. Now what is happening here? If you remember fraction, you can write it nicely. You'll have h square d over v square divided by h to be equal to 1, or a constant if you want it like this. Now what do we do from here? Remember, when you have a over b divided by c, it simply says a over b multiplied by the inverse. The inverse here is 1 over c. So now what we have here, it is h square over g over v square multiplied by 1 over h. This is what's happening, to be equal to c. So what happened? You can see 2 cancel with h. Do you guys agree? 2 cancel with h. What do you get? You get now the final answer to be here hg over v square to be equal to 1, or else you can call it hg over v square to be equal to a constant. This is the answer. Now you wondering here, you are seeing v over root over what there. Remember, this thing is equal to 1, v square. You can keep it like this, it is right. Or you can continue it further here. You make v square you can keep it like this, or what do we do? hv square d multiplied by the inverse, you have hg over v square. Yeah, you can keep it like this. You can keep it like this, because what they did, they simply brought this guy on the other side just for beauty. They brought v square on the right side, they brought hg on the other side. Remember, even if I put 1 on this side, I'm still gonna have 1 over 1, which still gives me a constant. That's what I'm saying. This is also right. And at the end of the day, what they did, they want to remove the square from the v, so you just put the root on it. So that's the reason why you have a v over root hg. So you should not worry about this answer. If you stop here, you are fine, you get the answer. That's the reason you only have one solution of pi, one expression of pi. It is this one. How do we know that? Because from the beginning, when we did the m minus n, it gives us 1. It gives us 1 here. Any question? We can tackle that second example quickly.
Mr. Ice, me personally, I'm lost. Can you please just start, not at the beginning of the formula, but at the beginning of that last part, you see?
Oh,
Please, man.
yeah, I'm here for that, my boss. Which last part, Mr. Roto? This one, where my hand is
Yeah,
showing.
the one you've been explaining here.
Oh, okay. But do you understand why when we cancel these 2 and everything?
Yes, for that too, I
You
understand.
understand?
And then
But
that last one,
now,
I'm
Mr.
lost.
Koto, we are here. We want to cancel time, but both our expression has time, and this one also has time. What do we do? Do you agree that if I want to cancel time here, I need to multiply by time square? Do that one you agree first?
Yes, that one I agree.
But now, what's happening? I cannot, when I say time square now, I need to use this time coming from this expression so that it can cancel. Now, this is what's happening. I need time square. I can make time subject of the formula on this first one here. This is what I did here. When you make time subject of the formula. Is that one fine, Mr. Koto? You can do it the other way around. You can even
Yes, yes.
express the other guy there. Now, when you do it, next thing, all I need is time square. That's the reason why I have squared this thing. I'm just following what's happening here. I have squared it, it gives me this h square and v square. Now, what's happening is, since I am multiplying here with time, I should also multiply with the variable of the time that I got. What is that variable? It is hv. But remember, I am multiplying time square. So this expression also should be square. Now, this is what's happening when we are doing the calculation, Mr. Goto. This does not look like this. It is looking like this because this multiplication is happening on the numerator. So also these guys here, you should multiply the value on the numerator. I know if you keep it like this, you might get it, in this case it's giving the same thing because it's the coincidence, but the way of doing it is it should multiply the numerator as we have done here. That's why we have h square v square multiplied by g divided by h. On the other side, you'll be having t square over t square, which is cancelling out actually. Are you still confused, Mr. Koto? You know what, Mr. Koto? Let's look at the second example. I'm pretty sure it will get clear then.
Second example. Yes.
Let's look at it. If it's not clear, then we'll come back. What's the time? What's the time? There on my clock, this will be saying 15 minutes. But let's look at the second example quickly. I'm pretty sure. Yeah. Okay, second example. All you have, they said for the drag force of the sphere fluid, whatever is just the theory. All they want to show you is the function f with it has variable of velocity, density. I forgot what is this mu standing for again, and then we have the distance. But as we can see, as we can see, as we can see, yeah, let's do this. Let's do this. Okay, what is the steps? This is the one that they call step by step. They said we have the drag force, a function force d, which is f in term of, what is it in term again? Let's check quickly. It is v density mu and d in terms of v density mu and d. Now what do? First thing, you can count your number of m. 1, 2, 3, 4, 5. Do not count this f. This here is simply to say it is function of. It is just a mathematical way of saying it. In math we do not write it is function of. We just put f and then we put the variable. So if you count the variable here, you have m5. Next thing is to identify our n. How do we identify our n? Our n will come out from these guys here. You know that when it comes to velocity, you know it is meter per second. So what is meter per second? It is distance, L over time. Already, remember the primary dimension that we know, it is mlg. Now what is density, Mr. Kotso? Density is kilogram meter cube. So what is kilogram? It is m, it is l cube. Now already I have one expression with m. Look, from these two I already have mlg. Do you see it, Mr. Kotso? Because this mlg is already showing in one of the expression. Definitely, without doubt, I know my number of n is 3. We simply have to have it from one of the expression. Now we move, Mr. Kotso. What is mu? For mu, what do we get? Mu is viscosity. Yeah, what is the unit of viscosity? So it's for you to remember the units, but if you don't remember, like me, I don't remember, I'm gonna write what they wrote as viscosity, mlg. So it means you need to remember it. You need to remember it. It is mass, length and time. What is this unit? Mass is kilogram. So viscosity unit is kilogram meter per second. Yeah, this is the unit of viscosity. If you don't remember it, d here stands for the distance, not diameter. It's diameter. Yeah, it's a sphere. Diameter is also in meter, which is what? L. So this is it, Mr. Kotso. First thing to do, we can get the number of pi that we should expect at the end. The pi values, we know it is m minus n. It is 5 minus 3, which gives us 2. So I know at the end of my answer, I'll have 2 answers. Now, what else do we do, Mr. Kotso? We put these guys on our table. Now I'm gonna write the table. I'm not gonna copy it. We all gonna do it together. You have variable, you have v.
So, Mr. Harris,
You say?
hey, Mr. Harris,
Yes, my brother. Talk to me.
I'm saying, you see, for those V is equals to L over T and those things, are they always the same? Like, as long as I know V is equal to
Yeah,
L
it
over
is
T
like that. As
forever
long
and ever
as,
for this to be this.
yeah, when you read, you see this question. When they say, they will tell you, when I say velocity, you know velocity is meter per second. It will always be L over T. All you need to remember here is simply the unit of the thing that they are talking about. If I'm talking about velocity, it is L over T. If I'm talking about diameter, you know it is meter, because diameter it is meter. If I'm talking about the force, you know force is Newton. Newton, it is mLT square. So all you have to know here is to remember it. If I'm talking about the force, you know what to use. But it is important to know them, because if you try to claim them, sometimes you can forget and get confused. But in this topic, yeah, it is like that, Mr. Kotso. It is like that. Now, you have V. It goes with its variable L over T. We are doing the table together. We have density. It goes with M L cube. What else do we have? You have mu. I think we should write also for the force aside. It should be written, yeah. The force is also ml t square. If I'm not mistaken, this is what we got for the force. So I can write it somewhere here. Up. Delete this. I can write the force up here. I can write it. They are calling it FG here under this question, but it's the force. FG is ml t square. It is better you keep the order that you have. Velocity, it is L T, but it doesn't really matter. You can do it the way you want. It's freedom. Science. Density, it is ml cube. What else do we have? Viscosity, ml t, and then we have the diameter, which is L. So here we go, guys. Now we're gonna come up with the derivation by cancelling. All we want an expression with these f, v, l, u, what, without the primary dimension. So how do we do it? You choose by each step to cancel one of the main dimensional. Like I said, always go for the easiest one. When you look at this expression, the easiest one to go is this one. I did not say you cannot go for the big one. You can go for the big one, but just it will give you big answers. And if it keeps giving big
Mr.
and big,
Ice.
yes, my boss.
Okay, tell me, is it possible to like use two, how do you call them?
Two at the same time.
Like, yeah,
No, no,
is it,
no. You
or
can't.
we
You
should just
cancel one at a time. You cancel one main dimension at a time.
one, so we can't cancel two at a time
No,
or
no, no. One
three,
at a time.
depending.
You
Just
choose.
one.
You
Ah,
can
okay.
decide to cancel the m's. It's up to you. Or you can decide to cancel the L, but like I said, you look at the expression, choose the one that is easiest one to go, my brother. Choose your battles. You can't earn 10k and you go for these girls. You know, my brother. You can't earn
That
10k and you go take this girl that will challenge your salary in 2 days. So you must choose your battle wisely. You must go to that one we can take 200 rand. There you are safe. So that's
the
basically
ice.
what's yes, my brother.
The viscosity, the one it's kg per kilogram per. Yeah,
It is kilogram per
per. Yeah,
meter per second. And what do they
it's
wrote here?
like a kilogram.
Here they said mass over LG. So it is kilogram
Yeah,
divided by meter times
meter second.
second. Oh, okay, 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 okay. What is it again? mLG. So please, if you don't get one thing, you can't remember, Unfortunately, you will have to climb it. I don't really like the climbing, but if that's how you remember it, it is what it is, guys. Let me just close this link quickly. It's 1 minute and send a new link, and we can continue our class just now. Oh God.
Okay, we know that after Cal touched the tail fin, he saw Daly in the glow, and Daly wanted Cal to stay there.
And then he bled back into the planet Eureka for a few seconds.
And then he disappeared again, I assume back to the glow.
That leads us back to our original question. How'd he get here?
I mean, his vitals are completely normal.
So what, he's comatose like the detainees?
No, no, not according to his charts. I mean, he has been sedated to make it easier to monitor his brain activity and vitals.
Sloppy.
What?
My calling. Wake him up. We have to wake him up. He could have information about the glow. Bill.
And he doesn't have the vapors they have pumped him full of ketofol.
We gotta get him to talk. Someone can come in that door any second now. Bill, can you hear me?
Did I ever tell you what my favorite movie was?
Shawshank Redemption, Arrival?
No, Pulp Fiction. It's nice to see a familiar face. Hi.
Angelina, you're alive? Did I bring you here?
We always seem to find a way to each other. We're connected, Cal.
No. I don't want to be anywhere near you. Bill, can you see me? Can you see me? God. Okay. You're gonna be okay, right? Now, can you remember anything about the glow or how you got here or when you got here?
Okay, he's trying to say something. It's okay. Hey, take your time. Take your time. Shit. This is exactly what Vance was trying to warn us about.
I can't believe it. You're not like this.
No, they catch us in here, they're gonna lock us up until it's reconfined for God knows how long. And then we are no use to Daly or anybody for that matter.
Chloe, we have to wake him up.
We did that already.
Okay, guys, let's continue. Let's continue so that we can win in terms of time. This is where we were. I'm gonna post. Okay, I'll post this video as well on YouTube. So I think we've corrected. You have to make sure that everything here is fine. So what do we do, guys? You know that the first variable that we are using here, we are cancelling using L. This is what we are doing. So you come with the first one here. Remember, L is going with D. So you have to be careful.
The first one. Mr. Ice.
Mm.
With D. So you have to be
Yes,
Mr. Ice.
yes, my brother.
You didn't change
That
the U. You only change it on top, not on the table.
oh, not on the table. Yeah, thank you, my brother. Hey, that was gonna mess us up.
The U.
Oh, the first was fine. It was ML. The U is M. Okay, MLG. Yeah, guys, if you get that unit wrong, remember, chances are high that you can fail the question. Now, Mr. Kotso, I want to cancel L everywhere, but remember L is coming with D. So now what do I do? Under this first expression, if I want to cancel L, what do I do? I have to divide. Do you agree? If I put L down here, it will cancel. But remember, if I divide here, I'm also dividing with this. So it means the new guy that I have here would be this FG here over D. Now it will give me under the new variable here mg square. This is what happened. You have FG divided by D this side to be equal to ml divide, remember, by LG square. So what we need, we cancel L. This is what we're gonna do for each element. We're going to be cancelling L. So when you cancel L for the first element, that's what you got. You got this expression. You get F over G. You are not only, remember, this thing is basically equal. It's not basically, it is equal. You see how it is written. This is equal to this over this. So if I'm dividing this side, it means also this guy should derive the variable. That's why we have F over D. Now, second guy, you do it separately. In each case, it depends on how you want to use it to get what you want. Now, you have V. What do you need? You need to cancel L. What do? You have to divide by L. But dividing by L also means dividing by D. So now under this case, you will be having V over D to be equal to what? It's gonna give me 1 over G, because when I divide, L get cancelled out. Now what do? We move to the third one. Now what is happening to the third one? I want to cancel L, but this L is cube. What do I need to cancel? If I want to cancel this, I need to multiply by L cube. Do you agree? It's just a matter of composition. It's quite of writing what you want. Now if I have to multiply by L cube, so what does it mean? The same multiplication should be done on both sides. That's the reason here you will have density times G cube, and the answer here was simply gonna be M, because L is cancelled. Any question, guys? Mr. Kotso? My brother, Mr. Kotso, any question?
All clear, all clear.
Okay. Now we move to the fourth expression. You want to cancel L. What do? You need to multiply by L, but L comes with D. That's the reason why you have mu D. Do you see it, Mr. Koso? Simply gonna give me M and Chi. M and Chi. Now remember, this is the guy that I used to cancel, so definitely you leave it empty like this. Now you are left with these guys here. It's empty and empty. Now you are get with this guy here. Now you are here. You look, which one is simple to cancel? M. Do you agree? The simplest expression here is M. But remember now, M comes with this expression, so you have to be careful when we are doing this. Here we go. Let's cancel M throughout here. Now let's go again to the first one. If you want to cancel M, what do? You need to divide by M. Now you have to pay attention. Now basically what's happening here, you will be having FD over D like this. Everything divided by rho D cube to be equal. Remember, you are cancelling M. If you put this divide by M, you will be having 1 over T square. That's what's happening there. So you have to rearrange what is here using the fraction, you get f. Let me not write fg, let me write it f to avoid confusion. F over g is going to be multiplied by the inverse here. I guess the inverse here is 1 over rho g cube. So what we will be having as answer is f over density d to the power 4. So the expression that we'll be having would be f density d to the power 4 with the parameters of 1 to the chi square. Let us just double check from the textbook if that's what they got under that expression. Yes, that's it. And this is how they got it. So I hope you see what we did here, Mr. Koto. Do you see Mr. Koto? Mr. Ubaka? Like I said, the video is uploaded. No, the video is there. No, the video, English. It's being recorded and I'll have to post it before I sleep. Otherwise.
So this other one, the second one, it's f over d times 1 over.
Where? F? This one? Can you please speak, Mr. Koto? So that
No, the one under, the one that says it's f over what? I can't see that it's f over something times 1 over
oh, it's
density.
F
Like, I
over
can't see
D.
there what's happening.
Oh, it is F over D. I'm just using the fraction multiplied by the inverse. The inverse is 1 over density D cube.
Oh, so it's just for the first line, eh? It's not the second line, that one.
No, I'm not getting your question, my leader. I need to get your question so that I answer you, my leader, so that we are good.
I'm saying for that part, you were just explaining how we got 1 over t squared.
Actually, what I was doing here, I'm cancelling M. Remember, I'm done with L. I need to cancel all my main 3 parameters. You need to cancel them. It's a must.
Mr. Ice,
Mm.
I think he's saying the second step below the first step on when you are calculating the final answer.
Yes.
He's asking, it's not for the second row, it's not for the V. That's what he's
No,
asking,
no,
if
no.
I'm understanding.
It's not for the V, Mr. Koto. It's still for the F.
Yeah.
Was that the question, Mr. Koto?
Yes, yes, yes.
No,
Thank
no.
you,
It's
man.
still from the F. Now I was just showing you the calculation I side how we came out with the new variable and the new parameter, the new dimension. This what actually happened. Like I was saying, we are cancelling M, but you on the first one. If you need to cancel M, what do? Remember, you have M t square. If you need to cancel M, you need to divide by M. Do you agree, Mr. Koto?
I agree, I agree. Thank you.
But if I do it on this side, I should also do it on this side. That's the reason why I took F over D divided by the expression of M. Do it both sides. Now, when you apply mathematics, we come up with this conclusion. So I'm gonna raise here and write that answer. So for the first one, when you cancel M, what do you get? For the first one, when you cancel M, you get the expression of F density D4 now with new parameter of 1 over G square. Now you move to the second one, Mr. Koso. Now, does the second one have M? No, it does not have M, so you copy the way it is. There is no M there to cancel, so you write it the way it is. You copy and paste simply. You only cancel where you have that M expression. what else, Mr. Klotso? Where's my mouse? Where is it? What are we doing? Now, we are here. We want to cancel M. What do we do? Did I miss something? Okay, this one is M over chi. I was thought maybe. Yeah. This one is the one that we are using to cancel, so we keep it empty like this. That's what it is. Now, this one we want to cancel M. What do? You are dividing again. So what you'll be having here will be density. No, it's going to be mu times d divided by density times d cube. So now remember what you will be having here. You have m chi divided by m. So this will cancel this. If we can rearrange this one, you'll be having mu over density d square. Remember these two can cancel to be 1 over g. So now, Mr. Grotso, we're going to have mu over density t square to be 1 over g. Now, yeah, this is where we are. Now, this is interesting. Now, this is what we had the similar case like this on the previous one, Mr. Grotso. We have three expressions with time. You need to choose one that you're gonna use to cancel on both sides. Do you agree that under this side, if you need to cancel t square, we need to multiply by t square? Do you guys agree? Are you with me?
Yes, yes.
Yeah.
Now, this one as well. If I need to cancel, I need to multiply by t. Now, you have another guy here. Now, like I said, when we have t, you have to choose one expression that you would be putting where you want. Like on the previous example, there were two. We chose one. We made subject of the formula and what. So the same thing will happen here, Mr. Kotson. But from the look of things, what I will do, I will choose this one. I will choose this one. Why? This one is simple compared to everything. Here you have F, you have density, you have this 4. Here you have mu, you have density, you have d cube. Here you simply have v over d. So now, when you have something like this, Mr. Kotso, what do? You can call it aside to make your life simpler. You can do it like this. Now, what do you do here? You are making t subject. Here you can do it aside. You are making t subject of the formula. So, means t here will be what, Mr. Kotso? D over v. It's gonna cross multiply. Chi will come here, v. This is your chi. Now, when I say that this one is t square, now we have to be careful, Mr. Kotso. This is now the new expression. This is v over g that give 1 over t. Now, me, I want to cancel. I need to have t as subject of the formula. That's what I've done here. Now, what I will do aside again, I can write t square. T square will be d square v square. Now, I will do the same thing that I will be doing. I will start with the first one. Do you agree that if I want to cancel t, what do? I need to multiply by t square. So now the multiplication will also gonna be done both sides. Look what's gonna happen, Mr. Klotso. We have f density d4 multiply by d square over v square. Why am I bringing it like this? Why am I not saying f over density d4 multiply by d square over v square? The reason being is t here that will cancel is multiplying the numerator. So this multiplication also should happen on the numerator. This is where we need to pay attention. So now, when we do this, we do the same on the other side. But remember,
Can you please repeat that?
okay, I was saying, Mr. Bubaka, if I have 1 over t square and I need to cancel, what do? I'm multiplying the numerator. Do you see it? I'm
Yeah,
gonna,
perfect.
sorry, it's t square. I'm multiplying the numerator. Now, it's the same thing that's happening even with the expression. The expression of t that you got should also multiply the numerator. Because when I write like this, d square v square, this is something else. These two are different. But let's see. I go tell you that I love you. Do you love me? Does it love you? Okay, Mr. Crowdsource. So that is what is happening there. So literally, this is what we are doing. So now on the other side, remember, G will be cancelled. So we are fine. It can be something like 1. So what's happening here? We can do the math here, Mr. Koto. We can do the math here. We can do f times d square. I'm doing it step by step so that you can see. Over v square. Everything divided by rho g4. So now we're going to have f d square, first equation, over v square, multiply by the inverse. Oh, this thing is giving everything the same thing. The inverse is rho over d4. Yeah, it's giving the same thing as what I was saying there. But let's do it like this to be safe. So now what does it mean, Mr. Code? So it means here g4 cancel, d square cancel this. So what you have here is f over, let me write it nicely, density velocity square, and then here you have d square. Let's just double check if that's what they got. Yeah, yeah, that's it. That's what they got, Mr. Rhodes, as expression. So you take, you erase, so now we have f, you go rho v square d square. Remember now you've cancelled the time. The reason why they put 0 on this side, because when you have this expression you do not have any main dimension anymore. That's what's happening. But remember, you chose this one to cancel, so you cannot use it again. That's what's happening. So this one is already out. What is the one left? Only one remaining is this guy. Let me erase here, guys. I will upload the video just right after the class. I will post it so that you can have a look at it. Now, what's happening here, Mr. Koto? Remember, we have the expression of chi. Now again, we need to multiply. So what's going to happen here? You will be having mu times d over v, everything divided by rho t square to be equal to something like 1, because time will cancel out. So we do again the same thing, Mr. Kotso. We have, yes. Hmm?
Why when you tell like T2 there, why do we get 0 and not 1?
Where I put 0 here?
Yeah, aren't you not supposed to get like t squared over t squared, which is one?
Yeah,
Or
t
am I
square over t
lost?
square is 1. Now, you cannot put 1 here. What we need, look how it works, Mr. Koso. We are writing variable, we write parameter distance. Variable, parameter distance. I mean parameter dimensions. Variable, parameter dimension. But when you have this expression, you do not have any parameter dimension anymore. Do you agree? That's the end. Because we do not have any parameter dimension, we say it is 0. It is not that the answer is 1, I need to put 1 there. The 1 there is simply to show that we have cancelled the last parameter distance. I mean the last parameter dimension.
Thank you.
Now you're welcome, my leader. So yeah, that's it, Mr. Kotso. So it's nothing check, so you can redo this, and so that's why I put 0 here, Mr. Kotso. The M is to solve if okay, what's the M of this thing? Is to use all everything given, variable and parameter dimension, to get an answer at the end without parameter of parameter dimensions. That's why we are cancelling them one by one. So we are doing the same thing here. We are also cancelling here. Here you have mu dv multiplied by the inverse, which is giving 1 rho this square here to be, let's say, to be equal to 1. So what happened here, Mr. Code? So d cancel this, so the expression that we got is mu over density times v. But now again, Mr. Code, so because we do not have parameter distance for this expression, that's the reason we put a 0 next to it. Now there's something that I want you to see, guys. I want you to see. Where is my mouse? What I want you to see is, look what's happening. Here what you get is mu rho v, and then here it is 0. Now what is happening here, my good people? You have at the end 2 pi answers. You have the first one, you can call it pi 1, which is f rho v square d square. You have the second one, you can call it pi 2, which is mu density v. Now remember, when you look at the formula of the, what's that thing again? When you look at the formula, where is it? When you look at the formula of the Buckingham theorem, do you see when they say pi 1 is equal to function of pi 2 whatever pi n? You can write it as well under this form, guys. You can write it like this. Now pi 1 is the guy, the main function, the one that we are looking for. Under our case here, Mr. Kotso and all my guys, Mr. Kambamba, Abubakar, we know that, where's this one? Why is this one becoming slow? We know that pi 1 is this one, pi 1 is 2. You can write it under this form, saying that pi 1 is a function of, let's say, pi 2. Now the reason why it is only pi 2 here, remember, we have shown it from the beginning. That's what I say, when you do this thing, you know what you're expecting. From the beginning, when you did m minus n, it told you that you should get 2 pi's answer at the end, and these are the 2. And if you do not get it, let's say you are getting 1 answer, therefore you are doing something wrong somewhere. So that's it. Let's do this. Now if you want to rewrite it under this form, Mr. Code, so simply what you are doing is f to be rho v square d square to be equal as function of mu rho v. So what you can do, you can express this f. It's up to you. You can leave it like this or express. It means you are bringing everything on the other side as function of mu rho v. Hopefully that's how you want it. Yeah, we can do it like this. Was there a mu here? Did we miss something? Then they got mu rho vg. What are we getting? What are we getting? Something is missing here. Mu. Yeah. Staccato. Let's see what we did wrong here. We need to fix this. We are getting mu rho vd. Okay, as we are using d over v, what is the expression that we are dividing? It is this one. It is mu rho d square. Let's say when we divide, let's bring it like this. Multiply by the inverse d over v. Yeah. This cancel this. The answer is mu rho vd. Not rho mu v. There's a d missing there. That will be missing. Mu rho vd. Mu rho vd. Okay, you can write it like this or like this. It's up to you, but you still get the full marks. What matters is the number of pi that you are getting. So guys, this is what we call the step-by-step method. So you guys are writing on Friday. So by tomorrow, you said it's page what, Mr. Code? So let me just type it. Example 8. By tomorrow we'll be done with this chapter. By Wednesday.
We'll be done with this.
By Wednesday.
Nice.
Yes, my brother.
Can you please send the book in the group, please?
Someone share it there in the group. Like, literally, it's in the group. Are you in the group, right, Mr. Kamara? If you
Yes,
check,
I'm in the group.
yeah, if you check right now,
I couldn't see it.
oh, this is not the, okay, those are the PDFs. Let me share the textbook now before I forget.
Thank you.
Love me, does she love you? Yes, guys, this is literally it. So what we can do, we can rest, and let me just talk to my daddy. Oh, hey Johnny. Hello. Come on. So guys, see you same time tomorrow. Ça va? Ouais, papa. Il est de la maison. Oh. Yeah, Johnny.